Assalamu alaikum. This is a question related to the polarization of light, and it is from May June 2022, paper variant 1 to question number 26. Two polarizing filters are placed next to each other so that their planes are parallel. The first polarizing filter has its transmission axis at an angle of 50 degree to the vertical. The second one has an axis at an angle of 20 degree. So it means the angle between both of them is the 30 degree. That's given in the question. A beam of vertically polarized light of intensity 8 watt per meter square is incident normally on the first polarizing filter. What is the intensity of the light that is transmitted from the second polarizing filter? To save time, I have already made a diagram for this whole situation, because mind mapping or sketching is very important. Sketching of a physics in the situation. In this situation, what physics tells you about a one particular topic, which is polarization of light, you must sketch it somehow. A rough sketch perhaps is always a good approach. So I have made a sketch here. See that? Here, over here, like this is the original intensity which has been vertical. It's been mentioned over here. The beam of vertically polarized light is incident normally on the first polarizing filter. So this is, and the first polarizing filter is at an angle of 50 degree. The second polarizing filter is at an angle of 20 degree. Now, if you apply Molu's law, right, you have studied in theory. I do not have to repeat it again. The Molu's law for the polarization amount, we can see that when this original intensity passes through the first polarizing filter, right, let's say this one emerging out from the first polarizer is I1. So I1 is now approaching towards the second polarizer. So the amount of I1 would be given as I0 cos square theta, where the I0 is 8 multiplied by cos square 50. All right, you will solve this one, and it is coming, in fact, 8 into cos 50 square something 3.31. okay, 2 decimal places. That is the intensity coming for the value of I1. Now when I1 approaches to the second polarizer, you should keep one thing in mind. The first polarizer has already rotated the polarization axis of the incident wave by an amount of 50 degree. Whereas the second polarizer, since at an angle of 20 degrees, so it means the second polarizer which shifted the first wave I1 back to the 20 degree. So it means the amount of rotation would be 30 degree when it approaches towards the second one. So I1, which is already 3.31, now multiply by cos square 30, and when you solve this one, let me solve this. So I'm getting something near 2.49 watt m minus 2. So it is supposed to be B. All right, so always remember, when we have the pair of polarizers, like in this situation, the first polarizer is rotating the axis of the incident light by an amount of 50 degree. The second will turn it back to the 20 degree. So it means the wave which is I1 coming towards the second polarizer has to come back by the amount of 30 degree. So the angle over here in the second phase would be considered the 30 degree, so that you can get 2.49 the answer. All right, thank you very much.